Hello guys, today I'll start to talk about the motion. Actually, these are the objectives of the new syllabus from Cambridge. Here we have the objectives for the core and the objectives for the supplement about the motion. So let's start our session. First, we want to differentiate between speed and velocity. Speed is the scalar quantity that has only magnitude without direction. But the velocity vector quantity that has both magnitude and direction. Like what? If I said the speed of the car is 20 kilometers per hour, only this. So this will be the speed because we have only value, only number, only magnitude without direction. On the other hand, if we talked about the velocity, I can say that velocity of the car equal 20 kilometers per hour north, 20 kilometers per hour east. So we have to add direction. So this is the velocity. The second thing about the definition for each one of them, take care about the definition. The only definition that will be accepted from Cambridge about the speed is the distance traveled per unit time. And this is the new definition for the speed. So as you see, here we have the speed is the distance traveled per unit time. And as I said, its scalar quantity has only magnitude without direction. The second thing about the velocity. What is the accepted definition for the velocity? Velocity is the speed in a given direction. Take care about the new syllabus. So the speed or the velocity is the speed in a given direction. And as I said, it's a vector quantity that has magnitude and direction. Both speed and velocity is measured in meter per second. And this is the base unit. The base unit for length is meter. The base unit for time is second. But maybe I can measure the speed in kilometer per hour. If I talk about the speed of the car, when the car travels between two cities, so actually I can measure the speed of the car in kilometer per hour. This is logic. Okay? After that, what about the average speed of an object? Actually, in Cambridge syllabus, the average speed, I can calculate it by dividing total distance traveled over total time taken. And actually, I can add another thing. Here, the first thing, as I said, for a whole journey, just total distance divided by total time. Total distance divided by total time. V equal S over T. Take care. Distance in the new syllabus, S, not D. So V equal S divided by T. This is for the whole journey. This is for just stage of the journey. Like what? If the car traveled from A to B and then from B to C, if I want to calculate the average speed from A to B only or from B to C, I can use this. Average speed equal U plus V over 2. U, which is the initial speed, and V, which is the final speed, divided by 2. So here we have two laws. We can use any one of them according to the given to calculate the average speed. Okay, you have two cars, ya shabab. The speed of each one of them is 10 meter per second. 10 meter per second. So actually the speed of this car is 10 meter per second and the speed of this car is 10 meter per second. This car moved to the right and this will be its speed. And this car moves to the left and this will be its speed. Actually, they have the same speed, but they have different velocities. Why? Because we have different directions. They have different direction. So the direction of this car to the right and direction of this car to the left. So we have change in the direction. So we have different velocity, but they have the same speed. They have the same speed as I said. If I want to calculate the velocity equal displacement over time. Why? Because the velocity is vector equal displacement also vector divided by time. If you talked about the speed, so the speed equal distance divided by time. Speed, distance, scalar. Velocity, displacement, vector. After that, let's talk about the distance time graph. Here we have relation between y-axis and x-axis. On the y-axis, represented by distance in meter, x-axis represented the time in second. Actually, here we have the blue line and here we have the red line. If the blue line represent blue car and the red line represent red car, actually, how can I measure or how can I compare between the speed of these two cars? Which car moves with a higher speed? The blue one or the red one? From the graph, because this came to you in the exam, so you have to take care. Actually, I can mention which car moves with a higher speed by just the steeper line. Which one is steeper than the other? Actually, the nearer line from y-axis will be steeper. So this means that the blue line that represents the blue car is steeper than this red line. So this means that the blue car moves with a higher speed than the red car, as you see. So this, if we compare between two objects, according which one moves with a higher speed. You have to take care about which one is steeper. You have to search about which one is steeper. So the nearer one from the y-axis will be steeper and will move with a higher speed. So here we have this graph represent, for example, a red car. So we have this one, stage, and this stage, and this stage. Actually, the first one represent steady speed. Steady speed means constant speed or uniform speed. So if we have just straight line, start from the origin, and we have distance time graph, so this straight line represent constant speed or steady speed. The second one about the stationary, as you see, this line parallel to the x-axis, and take care, we have distance on the y-axis. So this means that here in this stage, the car or the object does not move. Its speed equals 0. So we can say that it's stationary, at rest, does not move. The last one or the last line, also steady speed or constant speed, but returning back in the opposite direction. In the opposite direction, as you see. So we have steady speed returning to the start. How can we calculate the speed from the graph? Actually, we can calculate the speed from the graph by calculating the gradient or the slope from the graph. So here we have the speed is the gradient equal rise over run. If we have speed time graph or distance time graph, if we have distance time graph, we can calculate the speed just by getting and calculating the slope or the gradient. So here we have calculate the rise over run to get the speed of the graph. So here, ya shabab, in this question, he said a distance time graph is drawn below for a part of a train journey. The train is traveling at a constant speed. Calculate the speed of the train in meter per second. Actually, here we have graph relation between y-axis and x-axis. Y-axis, here we have distance represent on the y-axis, and here we have time represent on the x-axis. Distance in kilometer and time in minutes. You have to take care about the unit. You have to have a look to the units. What about the units? Yani maybe the distance in meter, the distance in kilometer, the time in minute, the time in hour, the time in second. So you have to take care about it. You have to return back to the graph to see the units of the two quantities that are represented on the y-axis and x-axis. So here we have the distance measured in kilometer and time measured in minutes. He asked you, Shabab, to calculate the speed of the train in meter per second. Actually, we said, so we can get the gradient by calculating the gradient of distance time graph. So here we have distance time graph. How can I get the gradient? You took it in math. Actually, you can use y2 minus y1 divided by x2 minus x1. But let me tell you something very important. You have to take large section from the graph to get its gradient, because this will be very interesting for the examiner that will correct your paper. It's better to get large portion from the graph to calculate its slope or its gradient. So here I'll use, he said, start from 0 And here this point, which is the last point here, actually we have to get this point, the first point, and I'll choose the last point, and then I have to draw the triangle, large triangle, to get the speed. So this will be x-axis, and here we have the y-axis. So now we have 6 minutes and we have 8 kilometers. But he said you have to get the speed in meter per second. So we have to convert from kilometer to meter and from minute to second. So here we have the distance, which is S. Don't write distance D, just write it S. So here S equal 8 kilometer. I have to change it into meter, just S equal 8 multiplied by 1000 to get 8,000 meter. Okay, and here we have the time equal 6 minutes. You have to convert it to second, multiply by 60. So we have 360 seconds. And then just divide 8,000 divided by 360 to get the speed. So the speed equal 8,000 divided by 360 to get the final answer of the speed. That will be 22.2 meter per second. So this will be the speed. So we calculated the speed from the graph. Just you have to get the gradient of distance time graph to get the speed. Gradient of the distance time graph. This is the first thing. The second thing, as I said, you have to draw large triangle to get rise over run, because this will be better for you to get full mark. After that, we have distance time graphs. We have this object and this object and this object. So we have 3 graphs. We have 2 straight lines and we have curved line, as you see. This graph, distance represented on the y-axis and time represented on the x-axis. Actually, if we compare between the blue line and the orange line, we can mention which object moves with a higher speed. As we said, you have to search about the steeper line. Which one is steeper? As you see, the blue line steeper than the red line. So this means that will be faster and this will be slower. Here we have curved upward. So this represents the object is accelerating, and I'll talk about it later. After that, what about the acceleration? Let me give you an example to explain the definition for the acceleration and the meaning for the acceleration. Actually, if you ride your car and you want to move to any city, you have a speedometer in front of you. This speedometer measures the speed in kilometer per hour. For example, if the speed starts from 10 kilometer per hour and then will be 20 kilometer per hour and then increase to 30 kilometer per hour. So we have increasing in the speed. So this change in the speed define the meaning of acceleration. This means that the car accelerates because we have change in the speed, change in velocity per unit time. So that will be the acceleration. On the other hand, what happened if I start to press on the brake? What will happen to the speed? The speed of the car will decrease gradually. So this means that we have negative acceleration, means deceleration. So here we can compare between the acceleration and deceleration. Acceleration increasing in the speed relative to time. What about the deceleration? Just decreasing in the speed. And we can say that the deceleration means negative acceleration. So this is the definition for the acceleration. Acceleration is the change in velocity per unit time. Take care about this definition. Change in velocity per unit time. Actually, this is the rule for the acceleration. A equal delta V divided by delta T. Delta V is the change in velocity, represent final minus initial. Final velocity minus initial velocity divided by delta t, which represent the change in time, tf minus ti, final time minus initial time. So here the average acceleration equal change in velocity divided by change in time. So A equal V minus U over T. Okay. After that, as I said, increase in the speed means we have positive acceleration, while decrease in the speed we have negative acceleration, means deceleration. After that, we have speed time graph. Actually, we have the speed and time. This, the first graph, speed and time, speed and time, speed and time. Let's describe each graph. The first graph, we have speed and time, speed on the y-axis and time on the x-axis. Actually here يا شباب, the graph will be the red one as you see, and this red one on the time on x-axis. So this represents what? The object does not move because he starts from zero speed. So the object stationary or at rest or does not move. The second graph, we have straight line. This straight line parallel to x-axis. This means that the speed does not change. So we have constant speed. We have uniform speed. So here we have steady speed. The third one, we have speed time graph, and we have the line. This line starts from zero, from the origin. So this means that we have acceleration. The object is accelerating. Increase in the velocity. Increase in velocity. So the object accelerating. The last one, we have speed time. We have this line that, like the hypotenuse, it will close the triangle. So this means that we have negative acceleration or deceleration. So we have negative acceleration or deceleration. The same thing here for the velocity time graph. We have 1, 2, 3, 4. Let's start to explain each one. The first one, we have the green line. This green line on the x-axis, this means that the object at rest. The object does not move. Its speed equals 0 because this object starts from 0. This line starts from 0. So we have at rest. And then we have this line that represents the constant acceleration. Take care. Here we have velocity on the y-axis. Velocity on the y-axis. If we have distance on the y-axis, so this will represent constant speed. But here we have, instead of distance, we have velocity. So we have constant acceleration. So if I want to describe the graph, I have to take care about the quantity that represented on the y-axis. If it is distance, if it is velocity, because we have change in the answer. So here we have constant acceleration. Then we have this line parallel to the x-axis, right? So this represents the speed does not change. We have constant speed or uniform speed. The last one, we have what? Increase in the speed or decrease in the speed? We have decrease in the speed. So we have constant deceleration or negative acceleration. Constant deceleration or negative acceleration. Working example. Ram decides to take a stroll to a park. He finds a bench in a quiet spot and takes a seat, picking up where he left off reading his book on the black hole. After some time reading from Ram realizes he lost track of time and runs home. A distance time graph for this trip is drawn below, as you see. Here we have distance in kilometer on the y-axis, and we have time in minutes on the x-axis. We have the graph. I can divide the graph into 3 stages: A, and then B, and then C. The question is, how long does Ram spend reading his book? Actually, when Ram start to read his book, he will not move. Is it right? So the distance will be constant. The distance will not change it. So here, if we return back to the graph, so I think we have this part, the first part, the second part, the third part. So this part, which is B, this part parallel to x-axis, right? And this is the graph that we have distance and time. So actually the answer will be stage B. Why? Because in the stage B, the distance does not change. Okay, so we have to calculate the time start from here and the time end with this point. So here, this is the first point, and that will be the second point. So the time here, 20 and 30, so we have 25 minutes. And here we have 60 and 70, so you have 65 minutes. Just subtract 65 minus 25, so 65 minus 25, that will be 40 minutes. So this is the answer for A. B. There are three sections labeled on the graph, A, B, and C. Which section represents the ram running home? Running, faster, higher speed, steeper line. So we have to search about steeper line. We have A, B, and C. Actually, we have A and C. But which one is steeper, as we said? A and C. I think C steeper than A because it's nearer to y-axis. So here, the section C represent the higher speed or steeper line. So that will be C. So this will be the answer. C. What is the total distance traveled by ram? Actually, the total distance start from 0 and end with this point. And this point actually represents any distance. Yes, 0.6 kilometer or meter. Take care, we have kilometer. So we have 0.6 kilometer. If he asked me to convert into meter, you have to multiply by 1,000 to get it in meter. Actually, let me tell you something very important. You have to take care while you are solving the questions. Exam tips in simple words. Actually, as I said, if he asked me to get the gradient, you have to choose what? You have to choose a big triangle for the slope. You have to choose big triangle for the slope. This will be very important for you. You will take full mark, by the way. So here, use a big triangle for the slope, as I said. And use a big section of the line, as I said. Don't use 2 points nearer from each other. Just choose 2 points far from each other. Another thing about the units, you have to take care about the units. You have to check, double check about the units on the y-axis and on the x-axis, because maybe the distance, it's always in meter, but sometimes he gave you the distance in kilometer, so you have to take care. The time always in second, sometimes he can give you the time in minute or hour, you have to take care. So you have to double check about what? About units, as I said, in the graph's axis. So in short, you have to draw a big triangle for the slope, as I said, and always check what units you are working with. Actually, we want to calculate the distance. If he gave you graph, speed, time graph, and he asked you to calculate the distance traveled, actually the distance traveled is the area under speed time graph. Distance traveled equal to the area under speed time graph. So here, if we have this graph, relation between speed or velocity, and we have time, and he asked it to get or to calculate the distance traveled, it will be the area beneath the graph. The area beneath the graph. So here we have this graph. We have this is the first stage, and this is the second stage. Actually, we can divide this graph into two regular shapes. to get their area. You remember how can we get the area? By using mathematical formula. So here I can just draw the vertical line here. So now we have, this is the first graph, which is the triangle. And that will be the second graph that represent rectangle. And you know that the area for the triangle is half times base times height. And the area for the rectangle is base times height. And after that, when you calculate the area for the triangle, which is the first shape, and the area for the rectangle, which is the second shape, then add them together to get the total area. That will be the total distance traveled. So here, area, which is half base height, and area, which is the base times height if we have the rectangle, and the first one if we have the triangle. Working example. The speed time graph below shows a car journey which lasts 460 seconds. Calculate the total distance traveled by the car on this journey. Actually, the total distance traveled is area under speed time graph. We can calculate the total distance traveled equal area under speed time graph. So actually, we have to divide this graph into many regular shapes. Then calculate the area of each one of them, then add them together to obtain the area, which is the total distance. So let's start the first one. I'll start to draw the vertical line. So we have the shape number 1, which is the triangle. And then we have rectangle. Okay? In this graph, how can I separate the graph into many shapes or into many regular shapes to obtain the distance or the area for each one? Actually, I can draw this vertical line till it reach the time, and then I will draw this line. So here we have what? Here we have 1, 2, 3, 4, 5 shapes. So this is shape number 1, second shape, third shape, fourth, and fifth shape. We can calculate the area for triangle, and then rectangle, and then this triangle, and then this rectangle, and finally the last triangle. As we said, area of the triangle half times base times height, while area of the rectangle length times width. So here we are. You can divide it, as I said, into many regular shapes and then get the area of each one of them, then add them together to obtain the total distance traveled. So this will be the first shape. Here we have triangle. How can I calculate the area of the triangle? Just half times base times height. So first, this is the first triangle. Here we have the base times height. Start from 0, end with 40. So this will be the base. What about the height? Till this point, which is from 15 to 20, it will be 17.5. So area of triangle, the first triangle, which is half times 40 times 17.5 equal. So this is the area of the triangle, the first shape. The second shape, the area for the rectangle, area of rectangle equal length times width. Start from 40, end with this point between 60 and 80, which is 70. So we have 70 minus 40 equal 30. So 30 times the height will be 17.5. And you can use the calculator to find the result of each one of them. 3. Area of, this is shape 3. As you see, this is triangle. So this triangle equal half times base times height. This will be the base, as you see, and this will be the height. The base from this point till this point. Here we have 70, here we have 90. So 90 minus 70 equal 20. So we have 20 multiply by the height. Height start from 17.5 till it reach 25. So here we have 20, but we have to add half. So we have half times 20 times this height start from 17.5 till 25. So 25 minus 17.5. And after that, area number 4. This is area number 4. We have rectangle. So number 4, area of rectangle. Length times width. The length we have here from 70 to 90, so we have 20. So 20 multiply by, start from here to this point, which is 17.5. So times 17.5. And the last one, number 5. Number 5, the area for the last triangle. So area of the last triangle equal half times base times height. The base start from here. What is this point? Start from 90 and end with 160. So you have to subtract 160 minus 90. It will be 70. So we have 70 times the height, which is 25 times 25. So half times 70 times 25. You can calculate each one of them and then add them together to obtain the final answer. So as you see, we can add them together to obtain the total distance traveled. So we have 350, we have 525, we have 75, we have 350, we have 875. Just add them together to obtain the total distance traveled. So here we have 350 plus 525 plus 75 plus 350 plus 875. Just add them together, you can obtain 2175 meter, and this will be the final answer for the total distance traveled from this graph. Okay? Calculating acceleration. Actually, if we have this graph, which is the relation between velocity on the y-axis and time on the x-axis, and if we have just this straight line start from the origin, this represents constant acceleration. And we can calculate the acceleration from this graph by calculating the slope or the gradient of velocity time graph. Just rise over run. You can choose 2 points. For example, I'll choose this point, I'll choose this point, and this point. And as I said, if you want to calculate the gradient or the slope, you have to choose 2 points far from each other to draw larger triangle. So I'll start to point or choose this point and this point. Then I'll start to draw this rectangle or triangle, sorry. So we have rise and we have run. Just dividing rise over run to get the gradient or the slope, as we will see in many examples later, inshallah. So calculating acceleration, it will be the gradient of velocity time graph equal rise over run. Actually, if we have these 4 graphs, we want to describe the situation or the movement of each one of them. How can I describe the first graph? First, we have, as I said, velocity, and we have time, and we have straight line start from the origin. Actually, this graph represents constant acceleration. So the acceleration at any point will be the same as the other point will be the same as the other point. So this means that we have constant acceleration. The second one, we have velocity time graph. And as you see, this line, sorry, this is the second graph. We have velocity and we have time and we have increasing in the graph. So this means that we have increasing in the speed. We have increasing in the speed. So we have acceleration or increasing the speed. But this represents acceleration or increasing the speed. Increasing the speed or the velocity. Increasing the velocity or acceleration. The third one, we have velocity time, but we have curve. We have curve for the graph. So we have decreasing in the velocity or deceleration. We have decreasing in the velocity or deceleration. Decreasing velocity or deceleration. While the last one, only we have just one line parallel to the x-axis. So this means that the velocity does not change. So we have constant velocity. Constant velocity. Okay. Worked example. Ziad is training for a cycling tournament. The speed time graph below shows his motion as he cycles along a flat straight road. Here we have speed on the x-axis, or sorry, on the y-axis in meter per second, and the time in second on the x-axis. A. In which section A, B, C, D, or E of the speed time graph is Ziad's acceleration the largest? We want to compare between the acceleration of these 1, 2, 3, 4, 5 graphs, 5 stages. Which one has the higher acceleration? As I said, we have speed time graph. So the slope or the gradient for this graph will give us the acceleration. The highest acceleration will be steeper line, the nearest one from y-axis. So which one is nearer from y-axis? A, B, C, D, or E? Actually, I think the steeper one will be D. So this means that, or this means that, this means that the answer will be D, because D is the steeper line. B. Calculate Ziad's acceleration between 5 and 10 seconds. Here we have 5 and 10 seconds. We can calculate the acceleration. We have speed time graph. So the acceleration will be the slope for this graph or the gradient, rise over run. He said from 5 to 10 seconds. So I start to draw vertical line till it reach the graph, and then horizontal line till it reach the y-axis. So it ends in 5. That will be the speed here. We have 5, and here we have just 10. So he said from 5 to 10. So this means that the acceleration between 5 and 10. So we can divide just 5 over 10. Y over x. So 5 over 10 equal 0.5. He said the acceleration, so it will be meter. It will be meter per second square. So the acceleration will be 0.5 meter per second square, because the speed in meter per second and the distance in or the time in second. So the acceleration will be meter per second square. About the examiner tips and tricks. As I said before, if he asked you to calculate the gradient, you have to choose 2 points far from each other to obtain big triangle. So the first thing about to get or to find the slope of the graph, you have to choose 2 points far from each one. And then draw a big triangle to obtain accurate result. Because the examiners, as I said, it will be interesting with the larger triangle to get a full mark, as we said. At which time the parachutist open his parachute? Actually, to answer this question, we have to talk about the free fall. Actually, in the absence of the air resistance, the objects fall with the same acceleration, which is 9.8 meter per second square, regardless to their mass. So here we have G, which is 9.8 meter per second square, near to the Earth. This is the acceleration if there is no air resistance. So all the objects, as I said, fall with the same acceleration, regardless to their mass. And we can represent this by drawing this graph, relation between speed and time, straight line start from the origin. What happens if we have air resistance? Let me tell you an example for that. When the parachutist jump from his airplane, so we have air resistance. So let's talk about the forces that will be effect on the skydiver. Actually, we have two forces, upward force and downward force. The downward force will be the weight for the skydiver, and the upward force will be the air resistance or drag force. Sometimes one of them will be greater than the other, and finally they can equal to each other. Let's talk about each stage. First, when the parachutist jump from his parachute, his weight will be greater than the air resistance. So the skydiver will accelerate. Then what will happen? The two forces will be equal to each other. The weight and the air resistance here will be equal to each other. At this time, the skydiver moves with a terminal velocity, means constant velocity. And at this time, the parachutist open his parachute. After that, what will happen? The upward force will be smaller or will be greater than. آخر واحد قولها لي تاني يا إبراهيم. من أول the upward force هتعيدها. The upward force will be greater than the downward force. So the person or the skydiver slows down. And after that, what will happen? The two forces will equal to each other one more time, and this will be the second terminal velocity. So we have two terminal velocities when the parachutist jump from his airplane. And we can represent what we said on this graph. We have speed, time graph, and this will be the first stage. As you see, we have acceleration, and after that, the person speeds up and air resistance increase. And here, as I said, we have the first terminal velocity, and this will be the second terminal velocity. But take care, the second terminal velocity much slower than the first terminal velocity. Okay? At this point, the parachutist will open his parachute here, because the upward force equal to the downward force, the air resistance equal to his weight. And this will be the second graph, the same like the first graph, the same. Thank you so much for watching my video, Shabab, and see you inshallah in the next session.